All right, just testing everything out. Testing my levels. Looks pretty good. Just testing the switching. All right, welcome. In this lesson, we're going to hit advance on. There we go. Welcome. In this lesson, we're going to start our quick start guide. We're going to start our Git and GitHub quick start guide. This will be part 1. In this part, I intend to introduce you to this. I will provide an introduction to this part and this series of lessons. And I will cover the core concepts behind Git. Then we'll walk through the installation of Git on Windows, Mac, and Linux. Now, in this Getting Started guide, since I want to go as fast as possible, I'm going to assume that you can basically walk through the installation on your own. However, I have provided full step-by-step. I do have full step-by-step instructions and videos for those that need that. Then we'll get into the main event, which is an introduction to Git using what I refer to as the remote first approach. That is, we'll start on GitHub, which we will use as our remote hosting service for our Git repositories. Then we'll clone down. Then we'll make a local copy, which we call cloning. And then we'll walk through the basic workflow, introducing the Git basic commands. Introducing the basic Git commands. And then we'll send our changes back up, which all of this combined together is a very common workflow. All right, I do have a few assumptions and target audience. I will assume that you have some basic computer skills and that you have not only the ability on how to install software, but you actually have the rights to install software. And that you basically have an understanding of the need for source control. Pretty much anyone who has worked on a project for any extended period of time and something devastating happened to their hard drive and lost all that work, you know who you are. You need source control. That would include freelancers, software developers, programmers, web designers, graphic designers, just about anybody that works with any kind of code. And that brings us to the value proposition for source control in general. And since you're looking at this, then I assume you're interested in learning about Git. And Git is the most popular source control tool out there right now. For my YouTube audience, If you're watching this on the live stream, I will make this video available immediately. It might be a little rough depending on how well this turns out, but I'll make it available for those that need that. However, inevitably there's going to be a few misquotes or lines that need to redo, so I will need to edit that all out and then upload a production quality version of this stream. I'll do this on this YouTube channel, so if you want to be aware of it, please subscribe to this channel. Also, I'll incorporate some of this into my Udemy courses. Since this is one of my freebies, this content will probably show up on one of my free courses. And also other platforms. So I do more than just Udemy. That brings me to my model. Basically, I do have to justify my time in doing all this. And the way that I do that is I introduce my concepts. And the way I do that is I start with short or intro courses, which I typically make for free. I post them to Udemy and YouTube and any other platform that I can. And then I also build up premium courses, which I make available on Udemy and other paid platforms. In addition to that, I've started using Patreon for those that like behind the scenes or the things that I'm currently working on that aren't quite ready for a course yet. And I'll be uploading as much premium content as I can there. So, if you like the way I do things, please support me there. I'm also available for private, team, or group consulting, which include private classes or group training like this. And I'll provide links in the description on the YouTube video you're watching. All right, a little bit about me. I am a lead software engineer and an online instructor. I've been a lead software engineer for the last several years, and overall I have about 20 years of software engineering development. I have about 20 years of software engineering and development experience. Currently, I'm on a continuous integration and delivery team, and I've become my company's resident Git and GitHub expert, which has allowed me to train many of my fellow developers in person at my current employ. And of course, that leads into my online training. So I've been training online for about 4 years. And currently I have over 18 courses on Udemy. And currently I have over 18 courses on Udemy and other platforms. All right, we're going to be starting with the command line. Now, I know some of you might be wondering why we would do that, especially if you're coming from Windows or another graphical interface. You might be wondering this might be like a step backwards. I totally understand, but there are some compelling reasons why. First of all, there's a lot of history, and because Git was designed from the command line first, any new features will show up on the command line before they would be integrated with any kind of graphical tool. And of course, this brings us all the power. So if you like the raw power of Git, then command line's your deal. But perhaps the most compelling reason, at least in my mind, is online help. It's impossible really to do very much online searching for something particular about Git without being given a bunch of commands. So if you don't know how the commands work, you're going to be lost. So try just searching anywhere, really. You go to the official website or Google, Stack Overflow, really anywhere, and you'll be given a bunch of commands. And the reason why is that it's consistent. Regardless of your operating system, whether you're on Mac or Linux or on Windows, all all the Git-related commands are identical. There might be a few very, very minor exceptions, but for the most part, it's all the same thing. Now, I had nothing against graphical clients. They're perfectly great. However, I feel like you should learn the command line first, and then tack on the graphical clients afterwards. I do this in my own work, and right now I'll probably split my time about 50-50 between graphical and command line. I found some commands are just a little faster on the command line. That's perfectly fine. And sometimes I just prefer a graphical client. But at least I know what's going on under the hood. All right, let's take a quick look at some key concepts regarding Git before we dive into the examples. Let's start with the Git repository. This is basically the collection of files and folders that's being managed by your source control tool. Now, really the Git repository is two concepts in one. We start out with a working directory, which is really your project folder that you have that is being managed by Git. And that would be someplace on your hard drive. However, there's a special .git folder at the root of your working directory that actually contains the repository. And that includes all history that's associated with your repository. So all different variations of the files as you check them in. Which would include all different versions of the files as you check them in. Next, let's look at the local states in Git. That includes the working directory, which we just covered, the staging area, and the Git repository itself. So this is part of the two-stage commit process, in which we start out with files on our working directory. So the files we can create or make modifications to that are within our projects folder. Then we're going to add those changes to our staging area. So at this point, they would be in both the staging area and the working directory. And then finally, we'll commit those changes into the repository. So everything in the staging area gets committed all at once in an atomic commit. At this point, any changes that are made into the repository through the commit process will affect the history of the Git repository. So this is the full process. We start with the working directory. Any changes, any new files or changes to existing files. We add those changes one by one or all at once into the staging area. Once we have built up all the changes we want to commit at one time, we commit those changes into our Git repository. However, I like to think of there being a fourth state, and that is the remote side. Now, it's perfectly fine to have a Git repository that solely lives on your system, but the usefulness of that is relatively limited. Most of the time, you're going to use a remote repository. That is, a repository that is not on your system in addition to your local repository. And we might use this in the case of working with other people on the same project on our team, we all agree that there will be a central repository that we'll all contribute to. When I look at this conceptually, I think of that remote repository as the fourth and final state. Now, technically, that remote repository has its own 3 local states, but from a conceptual standpoint, it's a 4th state over the overall process. So this is where we're starting out, and then we're going to push up our changes to the remote repository. So all the changes we've made on our local system are then reflected on the remote side. When I combine everything together, this is what the entire workflow looks like. We start on our working directory, add our changes to the staging area, commit our changes. We can rinse and repeat this process over and over again. And then, at some point, we're going to push all our changes that are different from our local repository all the way up to the remote repository. And when I'm referring to remote repository, I'm simply referring to a repository that's not in your local system. So that could be a Git repository that's set up at a team location, that could be internal, or it could be on a hosting platform like GitHub, BitLab, or it could be on a remote hosting service like GitHub, GitLab, or Bitbucket. And there's several of them out there. Those are the three most important ones right now. All right, let's talk about commits and the default branch. Commits are basically collections of changes at any point in time on a particular timeline. And the commits are identified by a SHA-1 identifier. However, you can actually reference them with an abbreviated first 6 or 7 digits of that SHA-1. A collection of these commits together can be on a timeline which we refer to as a branch. By default, when you create a new repository, you get a branch called master by default. Now, technically, we can rename the master branch, but we almost never do. It's a convention that I like to keep, and because that way you don't confuse anybody that's already familiar with expecting a master branch. All right, let's talk about installing Git. Now, I have an overview for the installation process for Windows, Mac, and Linux. Now, I do have individual install videos that go into much greater detail, so this will just be the highlights to go over what's really different from the standard process. So the process would be that we're going to install Git. There's going to be Git for Windows on, of course, Windows systems. On Mac, I prefer using the Commandline Developer Tools, which is provided by Apple. And on Linux, pretty much just use your package manager. The installation process is almost identical across the board. The only difference is which package manager command you use. After the installation process, I'll go over our minimal configuration that's required. And there's 2 more settings as well. And of course, if you want to see more detail, I have a video per operating system, so you can choose the video that's most appropriate for your system. It is fairly comprehensive, so it might actually be so you might think of it as a fairly long video for just covering an installation process, but I like being very thorough, and it doesn't leave anything out. And it is step by step. And for those that prefer to work with a set of instructions, I do have installation notes available on my website as well. And there are some people that just prefer, just give me a sheet with the instructions, I'll just do it. That way they can just knock it out in their time frame that they prefer, as opposed to watching a video. different strokes for different folks. All right, let's look at doing this on Windows. I'll be using Git for Windows, which is the official installer for Git from the official website. That's available from git-sem.com. You're just going to download for Windows. It should be available directly from the homepage. It should detect that you're on Windows and provide you the correct download. Now when you run the installer, most of the defaults should be fine. However, I do like adding the icon to the desktop, setting up Nano as my default editor, and when you get to the line endings page, I like to choose the middle option, which is check out as is and commit Unix style. That's because most of the teams I've worked with are now cross-platform. On Mac OS, I like using the version of Git that comes with Apple's Commandline Developer Tools. The only disadvantage I see here really is that the version that comes with the Commandline Developer Tools tends to be slightly behind. However, it is pretty easy and it doesn't cause any conflict, so that's one of the reasons why I recommend this approach. However, there is a small little tweak to this, and that is after major OS updates, you'll need to reinstall the Commandline Developer Tools. Now, I'm not talking about little patches where you go from 10.11.6 to 10.11.7. I'm talking about going from 10.11 to 10.12 to 10.13. For the last several years, I've always had to reinstall. And to get started, all you do is type git version. Now, if you already have Xcode installed, more than likely, Git will actually already be installed and you should get a version number back. But if it's not installed already, then you'll get a prompt much like this, where you'll be prompted to install the Apple Developer Tools. Now, you do have two choices here. You can click on the Get Xcode button, and that will route you to the Mac App Store to download the latest, greatest version of Xcode. Of course, if you don't plan on using Xcode, I don't recommend that, because it is multiple gigabytes, and it takes quite a long time to download and install. Instead, if you don't plan on using Xcode, then simply click on install, which will install only the command-line tools. As I mentioned before, after you do a major Mac OS update, you're going to have to reinstall the command-line tools. And you do that with xcode-select-install. Now, you might need to do this as sudo. In order to install this correctly. And once you've done that, verify that Git still works by typing git version. With Git on Linux, the Debian family, you just use apt-get. Again, you'll probably need to use sudo or log in as root. It'll be simply apt-get install git. Then you'll need to verify with git version. If you're running Red Hat or CentOS or a really old version of Fedora, then you can use yum to install Git. Again, you may have to do this using sudo or as root. And likewise, also use git version to verify. On Fedora, that is starting at 18, and it was made default in 22 onwards. You can use the newfangled DNF. You can use the newfangled DNF command, which is the successor to yum. Like all the other commands, it's basically the same thing. Sudo, potentially, or logged in as root, then DNF install git. Basically, all these package managers run the same type of install. Basically, all the package managers have the same way of installing Git. And of course, you'll need to verify with Git version. Regardless of the operating system you use, you'll need to set up a bare minimum amount of configuration. From your terminal, that is Git Bash on Windows, or from your terminal program on Mac or Linux, you'll run this series of git config commands. Basically, git config -- global that will save the setting to your user's home directory, then followed by the particular setting we're setting. So our first one is user.name, then in double quotes, your name. The second one will be user.email, then in double quotes, your email address. Now, if you're super sensitive about this type of thing, depending on which hosting service you're planning on using, you can see if they have a privacy-oriented email address you can use. However, most of the time this actually defeats the point of this does sort of defeat the point of setting up your email address. Those two settings are really the minimal configuration required. I do have two more settings I like to set: core.editor to nano and push.default to simple. Now the last setting is really just a way of getting rid of a nag screen that I've seen since Git 1.8, warning that really the default value for doing your pushes is changing. Now, since we're already past 2.0, which is when the change went into effect, we still had the nag screen for a little bit longer. So to make sure we don't get nagged anymore, you set the simple, then Git won't bother to tell you about it. Once you're done with all the configuration settings, you can verify the configuration by doing the git config -- global, then -- list. That will list out all the settings we've set so far into your terminal program. Great. Now let's get on to the main event, which is the remote work workflow featuring GitHub. However, before we can do much with GitHub, we do have a few initial steps we have to go through. If you don't already have an account, you do need to If you don't already have an account, you need to go ahead and sign in. You need to go ahead and sign up. If you already have an account, well, then you need to sign in. So what is GitHub? GitHub is basically a hosting service for hosting Git repositories. It also has additional features that either augment using Git or are in some way in support of Git. There are a few features that aren't related per se, but are good for project management. It is a fairly common misconception that Git and GitHub are the same thing, and they're not. GitHub is a hosting service, and Git itself is the source control tool. The GitHub service offers unlimited private. The GitHub service offers unlimited free public repositories at the free level. And because of this, it's become one of the most popular Git hosting platforms out there. GitHub is available at github.com. And then I'll walk you through the steps on signing in and signing up. You will need to have an email address you can access, because you will need to verify or validate your email. I walked through the sign up process a little earlier. When you first start out and go to the GitHub website, right on the homepage, you can sign up for an account if you don't already have one. Just fill out the username, email, and password. Pretty much in real time, GitHub will validate that at a given. GitHub will validate that your desired username is available or not. So make sure you type out something until you find a username that you're happy with and that is available. Once you've done that, click on the green Sign Up for GitHub button. Then you'll be greeted on another page. Now I will say one thing, and that is that I don't have any control over the GitHub website, and GitHub does have a tendency of changing things on a fairly frequent basis. So if the next few screens look a little different, then that means they made an update. Right now, I'm greeted with a verify account page. Right now, I'm greeted with a verified account page. So I simply click on the green Create an Account, which takes me to the next welcome screen. At this point, I technically have an account. By default, I'm given the free account, but I'm also given the option to upgrade to the developer account, basically a paid account. The difference here is that the paid account allows you to create private repositories. But we don't need that. For this course. The free account will be perfectly fine. As part of the sign-up process, you may be routed through. You may be asked a series of questions, like a survey. You can answer them if you want, or you can just skip along. Or you can skip this page. At some point, you'll be emailed a verification email. I have an example of the one that I got. Make sure you click on the link or copy it and paste it into your browser to verify your account. When you do that, you should get a screen that looks like this, where it says that your email was verified. This unlocks various features on GitHub. All right, now let's do the demo. All right, here I'm on my Windows machine, and I'm going to go to my web browser. As I mentioned before, I use Google Chrome as my standard, since it's consistent across all the platforms I support. I go to GitHub. I'm going to go to github.com, and once that page loads, I'm going to go ahead and sign in. Once you're signed in, you'll land on your dashboard. Now, in the future, this dashboard may change because because GitHub's always changing things. In fact, I kind of see that's going to happen because they're already beta testing the next version of the dashboard. However, from here, we're going to go ahead and create our new repository. So click on the green New Repository button. And that takes us to the Create New Repository page. We should have our username already populated as the owner, and we need to provide a repository name. I recommend using all lowercase with words separated by dashes. That's just a naming convention that I like using, but you can come up with your own. What's great is the web form here will automatically convert unsupported characters. For example, if you tried using spaces, it would convert them to dashes instead. This repository name just has to be unique for your account. I'm going to use GitHub-demo. Description is optional, but I like filling it out. This is a test repository for demonstrating how to use GitHub. Moving along, we are by default set to public, which you want to keep. Now, if you want to, we can try out private, and we are prompted to upgrade our account. We don't really need a private account. It really doesn't matter if the whole world can see hello world. Now, the last little bit here is the important piece. We want to initialize this repository with a README. So check that box. Now, the rest of this is not anything that we need to care about right now. So we can double check the form, and if everything looks fine, then we click on the green Create Repository button. Great. We should land on a page that looks like this. Of course, you'll have a different name up here because it should be your account instead of this one right here. We'll have our README file that we allowed GitHub to create on our behalf, and we start out with an initial commit. We have one commit that's right here, so we can click on that and see it. We can always click on the Code tab to get back to the main page of our repository. By default, we get a master branch. That's the default branch that you get with Git repositories. We can also see that by clicking on the branch item. You can see that it is set to default. All right, so we have successfully logged into GitHub and created our first repository on the GitHub hosting service. Now we're ready to do some things on the local side. Now that we have our repository set up on the remote side, let's switch context and go local. For now, I want to keep my browser available, so I'm going to keep it open like that, and I'm going to fire up my terminal program. Now on Windows, it'll be Git Bash, but if you're on Linux or Mac, it'll be the terminal program. I like to orient my screen such that I like to orient my windows such that I have easy access to both my terminal program and my web browser, because I'll be going back and forth. When I first log in, I should land in my user's home directory. We can double check that with the pwd command. That is print working directory. And in Git Bash, the way that it represents where we are, it uses the Unix style, and the way it handles the different drives that we're accustomed to on Windows, it prefaces that with a /drive name. So /c, then the path, /user/JSON, which is my name. I can see a list of files and folders here by using the ls command. ls is equivalent to the dir command if you're familiar with Windows. When starting out, I like to make sure that I group all my projects together in a single folder underneath my user's home directory. I typically call that folder projects. So let's make that directory now. mkdir, that's make directory, and then the directory I want to create, which is projects. Now if I do ls, I should now have a projects folder that I can go into. Now every so often I'm going to use the clear command to clear my screen for better viewing. Now let's go into that directory, cd, that is change directory, and into the projects folder. I'll also use the term folder and directory interchangeably. People coming from Windows are probably more familiar with the term folder, and those coming from Mac or Linux are probably more familiar with the term directory. For the most part, they mean the same thing. Yes, there are some very technical differences, but they're so minor it's not worth even bothering with it. All right, now that we're here, use pwd. You can see that I'm in the projects folder or directory underneath my user's home directory. At this point, at this location is where I want to create the copy of my remote repository. In order to do that, we're going to use a process called cloning. So we go back to our Git repository on GitHub. We go over here and see clone or download. We expand that out, and we see clone with HTTPS, which is what we want. You can select the entire text here and copy. That will copy to your clipboard. Or you can use the nice little button here that's a copy to clipboard button. Once you do that, let's head back over to our terminal program. And you can right-click and paste in the value. Or if you're on Git Bash, you can use the key. You can use the shortcut key, Shift Insert. But first I need to type git clone, and then use Shift Insert to paste in that URL. Once you've done that, press enter. Now, since it's a public repository, we weren't required to authenticate. All right. Now let's look at our projects folder to see what we have. Type ls, and we should now have a GitHub-demo folder within projects. By default, the git clone command will create a project folder named after the repository. Let's go into that using the cd command. So now if I do a pwd, you can see that I'm within the GitHub-demo folder underneath projects. You also notice that when we switched into the GitHub-demo folder, since it's being managed by Git, my prompt changed just a little bit. Now in parenthesis, it shows master, and that's the branch I'm currently on. And since we are currently in a Git managed folder, we can use our Git commands that are related to the repository. The first one, let's look at status. If you type git status, then press enter. The git status command tells us what the current state of our working folder is relative to our repository, and if applicable, related to the remote repository. So we see that we're on the master branch and that our branch is up to date with origin/master. Now, origin/master simply is a reference to the remote repository's branch master. That is our repository on GitHub. Whenever we cloned our repository, we got the remote reference named origin set up for us for free. And our master branch on our local repository is tracking against the master branch on GitHub. Furthermore, we have nothing to commit because we haven't done anything yet, and that our working tree, that is our working directory and anything recursively down from here, is all clean. Like there's no pending changes, no updates, anything like that Git is aware of. All right, while I'm here, let's look at the files that we have that are part of this repository. Now, I've been using the ls command, but I also have another alias called ll. That is another way of doing the ls command. So I've defined the ls command. So I've defined the ll command to basically be the equivalent of typing ls with the -a and -l options. If I do that, I get that output. It's just another way of listing my files and folders in this directory. And if I type ll, I should get basically the same type of content. All right, so we just created our project folder and cloned our repository into that location, and then took a little look around. Now, let's look at the Git folder. Now, let's look at the Git repository. So, listing out all the files and folders, we have the README file that we have, which is the same README file that we got for free when we created our repository. It's simply a markdown file, which is why we have the .md extension. And GitHub by default will render it for us. However, there's one difference here. The only entry that we have listed here is the README file. But if we go back to our local system, we see that we have that .git folder. As I mentioned before, the .git folder is actually where the Git repository resides. As I mentioned before, the .git folder is where the Git repository actually resides. So looking at my illustration here, the working directory is the directory we're currently in. That contains any files or folders that are part of our project that's being managed by Git. Then within the root directory of our project, we have our .git folder, which is the actual repository. That contains all the files and all the revisions of the files that's being tracked by Git. There we go. That looks a little better. All right, now that we've looked at the Git repository, let's actually go into that Git repository. Let's go into the Git repository folder, cd git, and you can see that when we go into the .git folder, that our prompt changes to warn us that we're in the Git directory. And it does that because really we have no major business here. It is technically a series of files and folders, so we can do an LL and see that we have a grouping of files and folders. All of this makes up the internals of the Git repository. Now I'm going to backtrack. I'm going to do cd space ... That allows me to go back up a level. So now I'm back in the GitHub-demo repository. So now I'm back in the GitHub-demo working folder of our repository. All right, that leads us to actually the two-phase commit process. We're going to walk through each of the 3 local states in Git on our way to create our first commit. We left off in the GitHub-demo working folder of our repository. That's underneath the projects folder within our user's home directory. To Git status, we have the same output that we had before, since we haven't done anything yet. And we really only have the README file. Well, let's change that. Let's use the command line tool, Nano, which is a command line driven text editor, to create a file. I'm going to call it start.txt. It could be anything, really. Once the text editor loads, we can type in anything we want here. this is an example text file. It really doesn't matter. I know that some people might be wondering, hey, why aren't you using source code or something like that, like Java files or Python or something like that? And the answer is real simple. It doesn't matter. Source code is text, and that's what Git actually tracks. Git tracks text files. Now, whether they happen to have a .java extension or a .py extension doesn't really matter to Git. It just tracks the contents within those files, which must be of type text. They can't track binaries very well, so the only option left are text files. All right, once you've typed in some content for your new file, we're going to exit out with Control X. Nano will detect that we have some changes in its buffer, that is, the area that we were typing, and give us the option to save those changes, which we want to do. So I'll press Y to continue. And although we've passed in the name of the text file when we launched Nano, Nano will give us the option to change the text file name. To keep it, simply type Enter, or simply press the Enter key. Now, if we do an LL, we should have a start.txt file in addition to the README file. Great. Now let's see what Git thinks of this. If we do git status, Git tells us that we have untracked files. That's just Git's way of saying, hey, this is a new file. I have no idea about it. I'm not currently caring about it. So as a reminder, the 3 local states in Git is the working directory changes, the staging area, and the Git repository, that is the committed changes. We currently have a new file in the working directory. At this point, Git isn't aware of it yet. We actually have to add it to the staging area for it to become aware. We can test that out because Git has another command we can use to see what files Git is tracking. It's simply git space ls-files. And right now, Git is only tracking the README file. It's the only file that Git is really aware of. I mean, it detects the fact that there's a new file in the working directory that it currently isn't tracking, which is what that message is about. So we'll accomplish 2 things at once with the next command. We'll tell Git about the new file so that it can start tracking it, and we'll move these changes, that's the new file, into the staging area. And we do this with Git's add command. Git add, and then the file you wish to add. Which is start.txt. Then press Enter. Now, if we ask Git for its status, we should have a slightly different output. Of course, it tells us we're on the master branch and that we're up to date with origin master. Now it says that instead of untracked files, which is what we had before, that we have changes to be committed. We haven't committed them, they're to be committed. That's just Git's way of saying you have stuff staged. So now we've done the add command, which moves our changes into the staging area. Now technically, those changes are in both the working directory and in the staging area. Like our new file didn't just disappear from the working directory just because we staged it. So staging is the first part of the two-stage commit. The next stage is to actually do the commit. Let's do that now. But before we do that, let's actually see if Git is tracking those files. Before we do that, let's see if Git is tracking the file. Git space ls-files. Now we see that we have both readme and start.txt being tracked. That's all we had to do. We didn't even have to fully commit the file yet. It started tracking the moment Git started tracking that file the moment we added it to the Git staging area. All right, now we're ready to do the actual commit. Git commit, and then I want to use an inline commit message. So I'm going to use the -m option, and then in double quotes, the commit message I want to provide. Adding start.txt file locally. That'll make it easy for me to determine where the different commits came. Where the different commits came from. Once you're done with that, press enter. And Git should respond with output that looks like this. The first line will be simply telling us which branch we're on and the commit ID that's associated with the commit, followed by the commit message that we provided. Now Git requires a commit message for every commit. It also tells us that we had one file change, that is the new file that we created, and it resulted in one insertion, that is the entire contents of that file. We also have a create mode, which is not terribly important. On Git Bash, it'll almost always be 644. All right. Now that we've done our commit, we've moved all of our changes that were in the staging area into the Git repository and its affected history. And we can see that commit by using, we see that, and we can actually see the details of that commit by using Git's show command. Git show, and then I'm going to use a special reference called head, all caps. Head is simply an alias for the last commit on the current branch. Now press enter. This shows us the details about our commit. We start off on the first line that we have the commit followed by the actual commit ID. That's the full SHA-1 identifier. We also see in parentheses that our head marker is pointing to master, or the last commit on master. Underneath that, we have the author information, which is myself, and in brackets, we have my email address that's associated with the author. We have the email address that's associated with the author information, which is what we set up in our Git configuration earlier. Then, of course, we have the date that the commit was actually committed, along with an indented commit message. The rest of it, we have a diff, but that's not important because we simply added a new file. Now, if you had longer text here, you might not be back on the prompt. If you find yourself in that situation, press the Q button to exit out of the git show command. All right, let's move along. So now that we've moved our changes from our working directory through the staging area and into our Git repository, all of this has been local. We haven't done anything yet to put our changes back onto GitHub. So this is the entire workflow we just went through. This is the entire workflow we just went through on the local side. Now, let's go remote. I'm going to send our changes back to GitHub, and we do that doing what we call a push. So this is where we currently are. We have our changes in the working directory and the Git repository. Of course, the staging area is clear right now because there's nothing pending there. We need to use Git's push command to send our changes up to GitHub. All right, let's look at this. Let's look where we are now. pwd, I'm currently in the working directory of our Git repository. Here are our files that are associated. And Git status has updated to let us know that origin master and our Git status has been updated to let us know that our branch, that is master on our local system, is ahead of origin master by 1 commit. That kind of tells us that, hey, we have stuff locally that's not available on our remote side or GitHub. We can see that by jumping back over to GitHub, and just to make sure, we're going to refresh our page. So basically, nothing has changed. We're still on the initial commit, and we only have a README file. All right, let's fix that. For that, I want to show you the origin. Before we do that, I want to show you the remote reference that we set up earlier. We can do that by using Git's remote command. Git remote and -v for verbose. Press enter, and then we have a remote name that is the remote reference that's named origin. And origin is set up by default whenever you clone from wherever you're cloning from. So we clone from GitHub, and and Git's clone command simply set up an origin, and Git's clone command simply set up a remote reference named origin, pointing back to our GitHub repository. And you can see that with the HTTPS URL right next to the name origin. Now it is listed here twice, and there's a technical reason behind that, but for the most part, it's going to always be the same thing. So both of these should be identical. It's extremely rare that they would not be. So now that we know what a remote reference is, we can use it in the next command. Git push, followed by the name of the remote reference we want to use, which is origin. It happens to be the only reference. It happens to be the only remote reference we have, followed by the only branch name we have, which is master. I like doing this the first time, although additional times we won't really need it. We'll press enter. And on Windows, if you set up the credential manager as part of the installation process, you should be prompted to log into GitHub like this. I'm going to go ahead and provide my username and password. Once that's done, click on Login. And provided that you actually provide the correct credentials, you should come back with something like this. Now, the top several lines are not that important. It's just internal stuff for how Git communicates from the local system to the remote system. The last couple lines are the ones that we're interested in. It tells us where we sent our changes to, which is our GitHub repository. Now, of course, the URL should be different. It should show your username as part of the URL. And if you happen to use a different name for your repository, it would be that piece would be different as well. And then the commits that were involved, exclusive. So the starting point and the ending point. And that we're pushing our changes from master, that is the remote side, that is the local side of master, to the remote side master. So from my local repository, the master branch, to the GitHub repository, the master branch. And that's it. This was successful. Now, the reason why we had to authenticate is because although my repository is public, it doesn't mean that just anybody can push changes to it. I still have exclusive control over my repository. All right, let's hop back over to GitHub and see if our changes are there now. Like we did before, I'm going to reload my page. And now this time, I should have the new commit message and the file we added on our local side. If I go up here, I see that I have 2 commits. And this will be in reverse chronological order. So down here at the bottom will be the initial commit that was created when it down at the bottom, I'll have the initial commit, which was created when we created the repository, and then the commit that we just added from our local side that was just pushed up here. And that's it. This whole process is the remote first approach. And we finally pushed our changes up to GitHub. So now our changes are in our working directory and in our local repository and in the remote repository. Here's a review of the entire process again. We start with our changes on the remote side. We start with our changes on the local side in our working directory. We added them to the staging area. Then we committed those changes, which affected our repository. Then we pushed any of our repository changes up to our remote. All right, well, that was it. Thank you very much for joining me, and please feel free to add comments below.